Hi everyone. Today let us try to solve some few problems on Thevenin's theorem. So let us try to handle one bridge network. Okay. So this is the problems on bridge network. So let us try to construct our own bridge and let us try to see whether the bridge is balanced or not. Okay. So in order to understand it better, I am taking one bridge network like this. So this is an voltage source and I'm going to give the input at the terminals 1, 2, 3, 4. Okay. So this is my bridge network and here I'm labeling this as 1, 2, 3, 4. So here I'm going to have the resistances. Okay. Resistor 1, resistor 2, resistor 3 and resistor 4. I'm going to make this bridge balanced. Okay, so this is 3 ohm. I'm taking this as some 2 ohm. I'm taking this as 3 ohm. I'm taking this as some 2 ohm. You see here the product of bridges. What is the product of bridges? 3 into 2 is equal to, what is the product of these two bridges? 2 into 3. So I can say that the bridge is balanced as per the given problem. As per the basics what you learned, the bridge is unbalanced. If the bridge is balanced, how much amount of current has to flow between 2 and 3? 0 amperes current has to flow. Whether it is flowing or not, let us try to verify it by using this analysis. Okay, so a load resistor is given and this is the RL given. We have to find out the current across RL for this circuit. So I'm going to exit this with an voltage of 2 volts. Let's try to see here how to solve the problem. So let us try to mark the current in this branch is some I1 current is flowing and current in this branch is some I2 current is flowing. Okay, so and the current in this branch I am marking it as some I3 current and the current in this branch I am marking as some I4 current. Okay, so now what we are going to do is so I am writing the equation for I1 is equal to I2 was one current I am going to find out, and second current I am going to find out it as I3 is equal to I4. What is this value? And you see here, what is the voltage at this point? You are going to have 2 volts. What is the voltage at this point? 0 volts. So the current I1 flows in this path. Is there any division of current? No. I can say that I1 and I2 are nothing but same currents of same magnitude. And how to write down the current? So current is leaving. What is the leaving polarity of the voltage? 2 volts. And what is the next leaving polarity? 0 divided by the sum of resistors which are connected in series. Okay. So you can see here these two resistors are connected in which connection? Series connection. Okay. Divided by R. There is nothing but 3 plus 3. Therefore, you are going to get I1 is equal to I2 is equal to 2 divided by 6. Okay, so which is nothing but 1 by 3, sorry, 1 by 6, sorry, 1 by 3. So what is 1 by 3 value? So 1 by 3 is nothing but 0.33 amperes is one magnitude of current. Now coming to this I3 and I4. So I can say that current I3 is equal to I4. The current is flowing in this direction. Whenever the current is flowing in this direction, how to write down the voltage? The current is leaving. I can write down it as a plus 2 minus 0 divided by R. So I can say that these two branches are again connected in which connection? Series connection. So therefore I can write down it as a 2 plus 2, which is nothing but 2 by 4, which is nothing but 1 by 2, which is equal to 0.5 amperes. So now you got two currents. So I'm going to construct this diagram like this. So this is an 2 ohms, sorry, 2 volts, and here I'm going to have this network is like this, and now we are going to reconstruct it to analyze the problem. Okay, so now you see this problem. So I'm considering the bottom end of the bridge. Okay, so when I consider the bottom end of the bridge, so I'm going to have 2 and I'm going to have the terminal 3, and already these two elements are joined at one common point where that common point is called 4. So now as you already calculated what is the magnitude of I2, so the current in this branch is 0.338. The current in this branch is nothing but I4. What is the magnitude of I4? We have been obtained is 0.5 amps. Okay, so when you are solving here, we need to find out two parameters. We need to find the equivalent circuit of Thevenin's theorem. So what is the equivalent circuit of the Thevenin's theorem? So already we discussed, we need to find out the open circuit voltage as the first step, and second step is finding out R Thevenin, and this is the equivalent circuit of Thevenin's theorem, and redraw the given resistance as RL. Okay, and we need to find out the current IL. So what is the voltage at this point? VOC. So I am going to get the formula for load current is equal to current is leaving. What is the polarity of the voltage? So VOC. So the current is flowing in this direction. Okay, so whenever the current is flowing in this direction, high potential minus low potential divided by R. What is the value of R? So this is nothing but R Thevenin plus RL. So now we are going to find out the first step as VOC and the second step as R Thevenin. So when you see this problem, I'm taking the half portion of this network. Okay, so now I want to find out the voltage across 2 and the voltage across 3 by using some nodal analysis. So when I perform V23, which is nothing but V2 minus V3, where this voltage is also called as a open circuit voltage. So what is this V23 and VOC? You both are same. Why? Because so while you are performing the experiment, you have to, so while you are performing, we will give the supply at 1 and 4. We will give the supply at 1 and 4, and we will be having a load resistor between 2 and 3. So we want to find out the current in this branch. That's why we are doing like this. Okay, so now this voltage measured between 2 and 3 will give you the value of open circuit voltage. So how to find out V2? So I can write down, so I want to write down this current. So I am writing this current as, what is the amount of current? 0.32 is equal to V2 minus 0 divided by branch resistance. So what is the amount of branch resistance given in the problem? So the amount of branch resistance is given is some 3 ohm. This is of some 2 ohm. So V2 minus 0 divided by 3, then you will get one value. The next one, V2 is equal to, so 0.3 into 3, so approximately you are going to get the V2 value as some 2 volts. So now coming to this branch, what is the current in this branch? So you are going to get 0.5 amperes, that is equal to, so the current in this branch is 0.5. How to write down that current? You can write down it as V3 minus 0 divided by R. What is the value of R? Which is nothing but 2. Therefore V3 is equal to 0.5 into 2. This is how much? Again 1 volt. Therefore V2 is 1, V3 is 1. So 1 minus 1 is nothing but how much voltage? 0. So the potential difference or the open circuit voltage you have been obtained as how much? 0 volts. So you got this open circuit voltage as 0 volts. So when you got this as 0 volts, and the second step is finding out RThevenin. Now how to find out RThevenin? Let us discuss. So we can find this RThevenin. So now we are going to find out this RThevenin. So how to find RThevenin is the second step. So how to find RThevenin is so if you have voltage source, so this is only one voltage source is there. This is of 2 volts. Make this voltage source as 0 volts. So this is nothing but generally we call this as this concept as deactivation. How we can make the voltage as 0? Just by short circuit that voltage source. So now I'm going to construct this diagram. So how many nodes I'm going to have? I have node 1, I have node 2, I have node 3, and I have node 4. So here I have the resistances. This is one branch, this is another branch, this is one more branch, this is another branch. Okay, so you have this as some 3 ohm, this has some 2 ohm, this is some 2 ohm, and this is some 2 ohm. So now I have been performed a short circuit between what two terminals 1 and 4. So these two terminals I have been short circuited. So now the same I am performing here. I am going to perform short circuit between 1 and 4, and I want to find out the R Thevenin between the load where we have is nothing but remove the load resistor and find out the resistance seen from open circuit terminal. I am redrawing the network for your analysis. So here you have 2 and here you have 3, and you see this network from 2 to 1 and to 1 to 4. So here this 1 and 4 I am joining with one common point. This is one common point between 2 to 1 and 2 to 4. How many elements are there? 2 elements are there. So between 2 to 1 I have a 3 ohm resistor. Between 2 to 4 I have one more resistor where that value is nothing but 3 ohms again. So now between 1 and 3 I have one resistor, 1 and 3 I have how much resistance? 2 ohm. Between 4 and 3 I have one more 2 ohm. Okay, so between 4 and 3 I have one more 2 ohm. Okay, so this resultant is nothing but 1 and 4 as common. So now when you draw this one, you can see here the current is entering. So current is entering and current is dividing. I can say these two branches are connected in parallel. So now these two branches are connected in parallel. Again the current is entering like this and current is dividing. I can say these two branches are connected in again parallel. So the resultant I am going to get here, which is nothing but 2 connected between 2 and 1 and 4. So we are going to get an resistor like this, and we are going to get between 1 and 3 like this. Okay, so you can see here these two are of same values. So how to do it? Product of resistance 3 into 3 divided by sum of resistance, where this is nothing but half of that value, which will be now 1.5 ohm, and this is nothing but you're going to get this as sum 1 ohm. So now the equivalent between these two, you can see here the current starts flowing from 2 and it reaches 3. I can say these two are again connected. Which connection? Series connection. Therefore between 2 as well as 3, these two are connected in series, which is nothing but 1.5 plus 1. So we're going to get this as some 2.5 ohms. So therefore when you see this problem, so you have got this open circuit voltage as 0 volts, and you have been obtained this Thevenin as 2.5, so 2.5 ohms. So this is the equivalent circuit. But actually when you see this problem, the bridge is balanced. Whenever the bridge is balanced, then what is the potential difference between V2 and V3? What is the potential difference? This is 1 volt and this is also 1 volt. The difference is 0. So the potential difference is 0. Whenever the potential difference is 0, when you connect an ammeter or when you connect an galvanometer, automatically it will indicate the current as 0 and saying that the current is not flowing. Whenever the current is not flowing, between V2 and V3, I can say the bridge is balanced. So this is how we can identify whether the bridge is balanced or not. Already before solving one, we have told that the bridge is balanced. In a balanced bridge, the current between 2 and 3 is 0. Okay, why? Because both are having equal potential. So this is how we are solving the problem, and this is the Thevenins equivalent circuit or the problem given for us. So you can solve, you can take of your own example and you can solve of your own. So this is one problem on bridge network. Let us try to solve one more problem on Thevenin's theorem. So the problem given here is, so hope you are able to understand. So if you want, I will repeat the problem again and again. So you see here, so here we have 2 volts, here we have 0 volts. I am writing the current I1 and I2 both are same. So current is V minus 0 by 3 plus 3, which is nothing but I1 current, and the current, I am writing this current like this, which is I3 and I4, which is nothing but 2 minus 0 divided by 2 plus 2, which is nothing but 4. So I find the current I1 and I2 which is flowing in this branch, and I find the current which is flowing in this branch, which are I1 and I2 and I2 and I3. So I obtained the two currents, one is 0.3 and next current is 0.4. So then I started applying the same here, 0.3 and 0.5, and I find the voltage at second node and I find the voltage at third node. So after finding it, so how to write down the current? 0.33 can be written as high potential minus low potential divided by R. R is 3 ohm. High potential minus low potential by 2 will give you the value of V2, and automatically we got the value of V3. So now the difference between this, when you perform the difference between, the potential difference is 0. It is indicating that V2 and V3 are of equal potential. Therefore, voltage is 0. The potential difference is 0. Automatically, whenever the bridge is balanced, the amount of current which flows by connecting a galvanometer. So when you connect a galvanometer like this, automatically the current which flows in the galvanometer is 0. It says that the bridge is balanced. So now, as per our analysis, without solving only, we had already told the bridge is balanced and 0 amount of current will flow in the network. So this is the Thevenins equivalent. And coming to here, how to find this value? Already I told uh, we are short circuiting between 1 and 4. We short circuited this branch, and here we have 3 ohms, and we have here 3 ohms, and we have 2 ohms here and 2 ohms here. So, and I am short circuiting between 1 and 4, and you can see here the current enters and current is going to divide. I can say this 3 and 3 are connected in parallel. These 2 and 2 are connected in parallel. When they are of equal values, is nothing but half of those magnitude. So you have been got. So now, so this is nothing but 1.5 plus 1. You are going to get it as 2.5. So this is the Thevenin's equivalent circuit. Let us try to solve one more problem on Thevenin's theorem. So the problem given is, find out the power loss across the load resistor 10 ohm using Thevenin's theorem. If the problem is not specified, then you can use the nodal analysis and you can find out using Thevenin's theorem. So coming to here, let's try to find out it. So the network given to us is like this. We have an 2 amperes current source. We have resistor 1. We have resistor 2. And this is one more branch given to us. And this is another branch given. And this is another branch given. And a current source is given to us. So this current source is of 5 ampere. This is of 2 ohm. This is of 1 ohm. This is of 10 ohm, where this is nothing but the load resistor, and this is of 1 ohm, and this is of 2 ohm. So the first procedure is finding out the VOC. Okay, So first we need to find out the open circuit voltage. How to find the open circuit voltage? First remove the load resistor and find the voltage across that open circuited load terminal. So I am redrawing the network as it is given. So when you open circuit this is going to act as some Vx node, and this is going to act as some Vy node. So this is the network we have in our hands. So this is of 5 ampere, 2 ohm, 1 ohm, and we want to find out where the voltage difference between these two is called open circuit voltage. So open circuit voltage is equal to Vx minus Vy. So if you find out, you can find out the open circuit voltage. Now how to find out these values? See here. So this is of 2 ohm, this is of 1 ohm. So now in this branch and 2 amperes current is entering. I am marking this. The voltage at this point is also the same voltage, which is nothing but Vx, and this is also voltage Vx. So now in order to find out Vx, how to find Vx is apply nodal analysis at node Vx. So how to apply the nodal analysis? So how to apply the nodal analysis is, you see here how many entering currents are there. One is entering current. So the remaining currents I am marking as this is of high potential. Current flows from high potential to low potential. Current flows from high potential to low potential. I am marking it as I2. So how many entering currents are there? 2 amperes is the entering current, and the leaving current. This is one leaving current, which is nothing but I1. The next leaving current is I2. So I am going to write down 2 is equal to, how to write down the current in this branch. So I am writing the current in this branch. This is plus, this is minus. Okay. So current is flowing. Whenever the current is flowing, the leaving terminal is Vx. So high potential minus low potential divided by, what is the branch resistance given in the problem? 2 ohm. So how to write down the current I2? So this is the current which is flowing. When the current is leaving, what is the polarity of the voltage? Which is nothing but plus Vx minus 0 by 1. So from here, we are going to solve it. So I'm taking Vx as a common term. So here I'm going to get 1 by 2 plus 1. So when you solve it, you are going to get Vx is equal to 1.33 volts is the Vx value. Okay, so why we are finding out all these things? To find out Vx and Vy. If you take difference, then you get Voc. So now I want to find out Voc. Already you can see here in this branch the current is coming like this, and I am assuming that current always flows from the nodal analysis as this is of high potential, this is of low potential. The current goes like this. So already I1 and I2 are marked. I am marking the current in this branch as some I3. So in order to find out Vy, we are going to apply nodal analysis at Vy node. So you can see here how many entering current is there? Only one entering current is there. That is 5 amperes is entering. And what is the leaving current we marked? The leaving current we have marked as some I3. So 5 is equal to, how to write down the current I3? So this can be written as Vy minus 0 divided by R. What is the value of R? R is nothing but 1 ohm. So therefore, Vy is equal to 5 volts. Vy is equal to 5 volts. Now, when you take the difference, so what is the value of Voc? So the value of Voc is nothing but Vxy is equal to Vx minus Vy, where we are going to get 1.33 minus 5 volts. When you are going to perform it, you are going to get minus 3.66 volts. So when you see this problem, so you have been got the value of Voc now. Now we need require the value of R internal. Okay, so how to find out this R internal? Let us try to do now. So the second step is finding out R internal. So how to find out R internal? You are very clear that. So this is an, so finding out R Thevenin is nothing but you have an current source of 2 amperes. So this is of 2 amperes. We want to make this current as 0. How to make the current as 0 means, so we definitely have to perform open circuit. So for this source, you try to perform open circuit. And also here you have one more source, current source is there. For this source also you try to replace this current source with an ammeter as open circuit, and this also as open circuit. So when you draw this resultant, you are going to get it like this. So when you are redrawing it, so here this is open circuited, and here you are going to have a 2 ohm resistor, and next one is a 1 ohm resistor. Next one, this is the load resistance. You have to remove this load resistance, and here you are going to have a one more 1 ohm resistor, and here you are going to have a 2 ohm resistor, and this will act as an open circuit. And we are going to find out the resistance seen from which terminal? These two terminals. See here, the current starts flowing like this. The current will divide across 2 1 1. So the current is dividing across this branch and this branch. So when now the current is dividing here, so we are getting some confusion, and that's why you just mark the as zeros. So here you got some confusion, so you can just mark it as a 1, and you can mark this as a some 2. So now we can easily identify. So between 1 and 0, we need to find out R Thevenin. See here, this is 1, this is 0. Between 1 and 0, how many resistors are connected? 1 ohm is connected. Between 1 and 2, how many resistors are connected? 2 is connected. So I'm going to get 1 resistor, where there is nothing but product of resistance 2 into 1 divided by 2 plus 1. So which is nothing but 2 divided by 3. So this 2 divided by 3, if you perform, you are going to get this as 0.66 ohms. And you can see here, so the current will start flowing like this, and current will not divide. So current will not flow in this path. Why? Because already the current in this path is 0. Therefore the current will not divide. Why? Because this is already open circuited. So the current directly will flow from 2 to 0. So from 2 to 0, you have only a 1 ohm resistor, and these zeros are joined. This is 0 and this is 0 are going to join, and you require the Thevenins between these two branches. Okay, so therefore the Thevenins between 1 and 2 is, you see here, just take the current. So the current flows in this branch like this, and the current is flowing like this. I can say that there is no division of current. Then these two branches are connected in parallel. So I can say that these two branches are connected in parallel. So between 1 and 2, you are going to get one resistor, and already these are connected in series. This is of 0.6, this is of 1, so which is 0.66 plus 1, where we are going to get the R Thevenin as R Thevenin is equal to 1.66 ohm. So now let's try to construct our Thevenin's equivalent circuit. So we had got VOC, and we had got R Thevenin, and we are having the load resistor where there is nothing but RL. So the RL given in the problem is some 10 ohm. Okay, so you can see here the RL given in the problem is 10 ohm. Okay, so RL is 10 ohm, and we have been got the value of VOC is minus 3.66 volts, and we have got this Thevenin as R Thevenin as 1.66. How to write down the current IL? Just use the formula what we had already discussed. So we had already discussed how to find out the Thevenins. Okay. So the formula for IL, the current which is leaving, is VOC minus 0 divided by R Thevenin plus RL. So what is the VOC value? Minus 3.66 volts minus 0 divided by 1.66 plus 10. So when you perform this, you are going to get the current which is flowing is nothing but minus 0.313 ampere, which is flowing in this direction. So if you take this direction, so the current is flowing in which direction? Clockwise direction is 0.3. And if you take the current in opposite direction, like counterclockwise direction, then you are going to get this IL as a 0.313. So getting positive or negative current is nothing wrong, but you have to see where the polarity and how the voltage source is present. So this is how to find out how to find out the load current. If you want, I will repeat the problem again. So this is the problem given. So first, in order to find out load resistor, first remove the load resistor and find the voltage across Vx and Vy. So Vx minus Vy will give you the Vx minus Vy will give you the value of Voc. So in order to find that, I have been applied the KCL at this point, and entering current is 2 amperes. The leaving current is Vx minus 0 by 2, Vx minus 0 by 1. So we are going to find out the nodal analysis at this point. Entering current is 5 amperes, leaving current is Vy minus 0 by 1. So by that I find the value of Voc. Now I want to find out the Thevenin's equivalent. The given two sources are independent sources. Therefore, I have to activate this voltage current source and this current source. I'm making it as open, and I also making this as open. Therefore, current flows in 2 ohm and 1 ohm. And the equivalent circuit is like this after replacing with equivalent resistance. Before the current starts flowing like this, and now the current flows like this, I can say that the current is divided, then these two resistance are connected in parallel. We had obtained the value of parallel, and this current will start and it will not flow in this branch. Therefore, since already this is open circuited, so there is no use of this. The current will flow directly like this, and you are going to get +1. Now when you see this, the current is constant. These two are again connected in series. Then you are going to get the value of R10. Just directly substitute in the one problem, then you are going to get. So if you feel the content is useful for you, please like the video and share with your friends and give your valuable comment positively. Hope the things are very useful for you. If you feel the content is useful, just subscribe to the channel. Yours now.